Hi, good evening, everyone, and welcome to the third day and the final day of this workshop on Numpy and Pandas, basically for data wrangling and for data science work. So on day one, we discussed Numpy, covered its basics, and yesterday we covered the basics of Pandas. So today we will practice how to use Pandas for our machine learning work. So with that introduction, I will just start sharing my screen so that we straight away jumping into the hands-on coding. Okay, I hope my screen is visible. Can somebody gives me a hands up? Okay, thank you, Rasika. Thank you so much. So, okay, so let. Okay, so yesterday we had covered pandas and how to read files, various type of files, how to find the data by column wise, by the row wise, using log or by using ilog, and how to use the indexes. So today we will now use pandas, how to manipulate the data and how to do the various steps of a machine learning model lifecycle. So for that, I have kept a very simple data. I have kept in the column. So we will read that data. So before that, I have to import pandas SPD. We'll do that. And this session will be interactive session. Anytime you feel to ask anything, please ask that. We will also import numpy as NP. So let's read this data. Okay, we have read this data. So for seeing the first top 5 rows of a data frame which we have loaded, the command which we use is known as df.head. And in the bracket, you can get the number of rows which you want to see. Okay, somebody wants to. The default value, when if you don't give anything inside the bracket, the default value is 5. Otherwise, you can get the number of that. So this will give you the first 5 rows of your data set. So as we can see in this data set, we have got 4 columns: duration, pulse, max pulse, calories, and we have got 5 rows. Now, if I, for example, I want to see 10 rows, I will give 10 inside this bracket and I will be able to see 10 rows. Similarly, this, if I want to see 2, for example, here, so we can select 2 also. And similarly, to see the last rows, we use the command tail. So we can see df.tail. So default is 5. It will give me 5 last 5 rows. Now, if I want to see, for example, from 20th to 50th row, then I can give inside bracket with this 20th to 50. So it will give me starting from 20th. 50 is excluded, so it will give 20 to 49. So this is how I can read the rows. Now see, I can use the iloc also. So from 20th to 30th, and I want to see the second column. So using the iloc, I can have that. So see from 20th to 29, because 30th is excluded, and column I gave second column, which is max pulse. So here I'm utilizing this iloc, which we deliberated in detail yesterday. Now I know the index is starting from 0. So I can use lock also. And with lock, I have to give index names and the column names. So I'm giving from 20th to 30th, means from index 20th to 29th will be read. And I'm giving the column duration. And using lock, I can read that also. So see here, 20th to 30th is given and column has come duration. Now, first thing which we do in a machine learning model, whenever we do a project, we load the data. So that we have seen yesterday, how to load the data. If it is in CSV format, we use pd.read_CSV and we give the file path inside the apostrophes. After loading the data, the first thing which we do, we want to field the data. We want to know the statistical information of the data. So for that, the command is df.describe. So df.describe, when we do, it will give me statistical information. So it starts for every column. It will give me count that how many number of values are there. What is the mean if it is a numerical column? What is the standard deviation? What is the minimum value? Then what is the 25% quartile value, 50% quartile value, 75% quartile value, and what is the max value? So when I see this data, immediately I can feel about the skewedness without even visualization. So this is the first thing which our data scientists do. Okay, after loading the data, the first thing we see the statistical information of that. After that, we want to know the structural and technical summary of that. So for that, the command is df.info. So df.info, let's see what it all will give. So in df.info, for every column, it will give me non-null count, that how many non-null values are there. So from here, immediately I can come to know that there are how many non values are there, blank values. So for example, we can see that in calories, there are 5 values which are blank. I can come to know what is the data type. So duration pulse and max pulse is a int, contains int values, whereas the calories have got float values. So this is the third step which we do. By using this immediately, we can come to know. There is another command I will just use here only. If I want to know, for example, nan values, so for that we use df.isNA. So isNA, if I type it, then for everything it will get true, false, true, false. So where it is true, it is a nan value. So what we do, we take the sum of that. So when we take the sum of that, it will immediately give this command df.isNA bracket.sum. Immediately it will give me nan values for the column. So here I know that calorie column has got 5 nan values. After doing this, I will find a strategy which I will discuss later, how to fill the nan values. So this we do. Then we also can find the unique values in a column. For example, I want to know in duration, what are the unique values? So I do that. And immediately I come to know that in duration, these are the values which are there. Now for that, if I want to know how many times they are occurring, then the command which we use is value counts. Df duration dot value counts. So here, immediately it will go in a sorted way that 60 which is there, it is occurring 79 times, 45 is occurring 35 times, and like so. So from here, I can get an. I also can check what is the mode, what is the median. So already that information I saw during df.describe. But if I want to see here also, I can see what is the mode. So we can see the 60 is the mode because it is the most frequent value which is coming. Now checking nan values, already I have covered this. How to check? We use isNA and we check isNA sum. We also can check nan values for column wise. But if you check for the entire DF, immediately you come to know about all the column. So that is not needed. Just for the demonstration purpose, I'm doing this. Now this was for feeling the data. When you load the data, you get the statistical information. Thereafter, you get the technical summary. Then you check it's whether the nan values are existing or not. So that we feel the data, how the data is felt using pandas. Now, second step comes data cleaning. So data cleaning basically means how to fix the bad data in your data set. Now, the bad data could be empty values, that is the nan values. Data may be in wrong format, that it was in something and suddenly it has come in a string, or there is wrong data also, and there may be duplicates. So that comes under the data cleaning process.
How many kinds of nan values are there?
Nan value is only of one type. Nan means nan, it is not available. Okay.
In the literal, if it is blank, it is not nan.
If it is blank, not available, then it is nan value.
Okay, it is 0, then 0.
Then it is 0, then it is not nan. 0 does not mean nan.
Or in the literals, it is taken nan, then it is an nan?
Then it has to be np.nan. If you type nan, then it is not nan.
Okay.
then it is a string nan.
Okay. Okay.
Okay, if you have to fill, for example, for this demonstration purpose, I am filling this from 12 to 23rd row, which is there, and
Hmm.
duration, and I'm filling with it with np.nan.
Okay.
Okay, so if it is nan, then it is a string. Again, I'm repeating.
Okay.
Okay, so here I'm filling this with nan value. So now when I check the nan values, so I can
Yeah.
see
Yeah.
I've got nan values now in duration, 12 values have come, and already there were 5 values, nan values in calories. Now, what
Hmm.
are the choices? How to handle the nan values? This is a very most frequent question which is asked during the interviews. How do you
Yeah.
handle nan values? So there are various ways. The first way is that you can say that, sir, I will delete all the rows. But it will depend on the proportion of your data which is having nan value. For example, if you are having 1 million rows and there are just 10 rows with nan values, I can take a call that, okay, I will discard these rows because it will not affect my machine learning model. But if a significant proportion of rows are having nan values, then I have to find a strategy to fill those nan values. Okay, so first choice which is there to remove the row, but it may not always be the correct choice. Now, for that, for example, if you have taken that strategy, then there is a single command which is there, which you have to do. You give new df is equal to df dot drop na. Okay, when you use this drop na command, it will drop all the rows with nan values. So we can see, for example, we have dropped it and then we print the new df, what it will give. So see here, it will drop those nan values. Okay, so we can see here in the index after 10, 11, from 12 to 23, they have been dropped. Okay, so those rows, they have been dropped and we have got a new data frame. So that is the thing which we do when we follow the strategy to drop. However, that will depend on the proportion of the number of rows out of the total number of rows of your data. Now, what is the other way? Now, for example, here, if I see after doing this, I check nan values. So see, we have removed all the nan values. Okay. Now remember this, by default, always the drop na method which is there, it will always returns a new data frame and it will not change the original. However, if you want to change the original, then you can do df dot drop na in place is equal to true. So if you do that, then it will remove all the rows in place and the df, you will get a new df without any handle. So now again, we come to df.info. So we,
Pardon, one second, sir. What we will do in place is equal to true. Please, one second.
okay, yes, yes. So I will cover here, for example, here what we did, I will just cover it here, state A. So I do df dot is an a dot sum. So see here, we have got 12 plus 5, 17 nan values. Now, if I do df dot drop na, just drop na, what it will do? It will remove
All.
all it has removed. But you see, again, if I see df dot is na dot sum, so again, it will give me the nan values. So if I'm doing this, I have to convert this into a new data frame, new df. Okay.
Okay, that is but that the DF is NA is showing only, that is view purpose only.
No, it is meaning that when you use drop na and without using in place is equal to true, so then it is removing only for the view purpose, but your original data frame is not getting changed.
Yeah.
Okay, if you want to change the original data frame, then you have to use in place is equal to true. That I'm not doing because I don't want to tweak with my data frame, because I have to demonstrate you other things also.
That is not a good practice. Also, we should take another data frame. It is better, right?
Yes, 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 you're right. Okay. So
Okay.
that in place command which is there, it will come handy in many places. So remember that in place is equal to true command. That is an important command. Okay.
Sir,
Okay.
may I ask you one question?
Yes, please.
Uh, you in the print command you said dot something to string. What is that for?
Which one? Which one?
Sir, if you go up, scroll up.
Yes, yes. So I am just for the printing purpose to give you. Otherwise, I would have printed the entire data set also. Okay.
Dot, to string. I mean, you
Yes,
print
to
command. I mean, go
yes,
go down.
yes, 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 yes. I have got your question. So
Yes.
see, I have converted that df which is there to a string just to better visibility. Otherwise, I could have printed you a df movies access. No, no. I have got your question. So I'm just for basically printing purpose. I have used that change to string. Okay. Otherwise, it would have come in this format.
Okay, sir. Okay, okay. Got it.
Okay.
Otherwise, it can't view, right? In some dot
Yes,
dot.
yes,
It will not show
yes,
all the rows.
yes. Okay. Here it was, if I'm not wrong, it was there. Okay. So data cleaning we have seen here. In that we have seen, okay, in place I have covered. In place is a very, very important command. It will come handy in a lot of places. So
Here it
for
is.
drop
Just above two string is there. Just above.
above. So this is for the string. See, this is giving you
Yeah, here.
two string. So I could have changed it to just print new df also. Then it would come in a format of a df. Okay. Okay. So I have changed the string basically to have all. Okay. So all the rows are visible to you.
Yeah, the rows are
Okay.
cut in bit, not shown.
Yes. Yes. Now there is another command. If, for example, now uh, one strategy was to for handling nan values was to delete. So for that command is drop NA. But second is that, for example, when you know that I have got significant proportion of rows with nan values, then the second strategy is to fill those nan values with something. So for that command is fill NA, and after that we give what do we have to fill with. So for example, here I'm taking a choice. I have from some imagination, I have decided I will fill it with 130. So I have given fill NA 130 in place is equal to true. So this in place is a very, very important command. We also can fill. Now, if I fill df.fill NA 130 in place is equal to true, it will fill all nan values irrespective of the columns with 130. But I also can take a call that I will fill only calories with 130 in place is equal to true. Now, this I'm just covering for the demonstration purpose only. In real world, you will never do this. You will never fill all the columns with a single value. For that, what you will do, you will check the distribution of data. So if it is a numerical column, you will check the distribution of data. If it is normally distributed, then you would like to fill the nan values with the mean. If it is right skewed or left skewed, then you will fill it with median. And if it is a categorical data, then you would like to fill it with mode. I hope that is clear. That is another very, very important question. It is asked during interviews that how do you handle nan values? What is the strategy to fill the nan values?
So here also in plus two is means the original data frame will be changed, right?
In place is equal to true, it will be catchy.
Okay.
Okay. So for
Sir,
example,
can you repeat again which value we want to put mean, median, and mode for which
okay. So
data?
again, I will repeat, please pay attention. We can have two types of data in the columns. One is numerical data. Second is categorical data. If it is a numerical data, I will visualize the distribution. That visualization part I will cover during my workshop on Matplotlib. So during visualization, if you find that your data is normally distributed, and then you will use mean. to fill the NaN values. But if you see the data is left skewed or right skewed, which you have learned during statistics 2 course, then I will use the strategy to fill NaN values by median. In case the data is categorical, then I will use the mode. Is it that clear?
Yes, sir.
And okay, very nice. So for example, for calories, I have decided that I will fill NaN value with mean. So first I calculate the mean, x is equal to df calories dot mean, and then df dot fill NA calories, column name, followed by x in place is equal to true, then it will fill it.
So you put direct the right RHS of the first x value, directly calories is to that. It will take.
Yes, that also will be do, but it will not be pydantic.
Okay.
Pydantic means it. Yeah. So now after this, we can see what is the df dot is NA, whether they have filled or not. So see, my calories, all the NaN values, they have been filled. Okay. Now, similarly, if you want to fill it with median, you can change with the median also. For example, we will fill, for example, duration with the median. I will just copy this and let's make a new. Change it to duration and we change it to median. Okay, so here see, we have filled the duration with median and now there are no NaN values. Now, please pay attention. If we have decided to fill with mode, then we have to be very, very clear because we know that we can have 2 modes also in a data set. We can have more modes also. So when you okay, so when you find the mode, for example, I have decided x1 is equal to df calories dot mode, then I have to select value x is equal to this value 0, means the first mode which is there, or the second mode. With that, I have to fill. So that is the only difference when you fill NaN values with mean or median or mode. So in mode, we have to be careful.
Okay. Is it compulsory to take the first value only?
You can take a call.
Okay.
For example, if 0 and 2, they are the most frequent, you can take 0 or 2. Okay. Okay. I'm not going into the statistical methods or covering the data science, but for filling NaN values, you can think, you can correlate that how that column is related with other columns. Okay. So that is also there. Okay. Okay. Now, dropping rows, we had seen during when we decided to drop the rows with the NaN values. Now, we also can use the dropping of the rows to remove the rows with outliers. So when we see the df dot describe, here that can give me a feeling how many outliers are there. But here in this data, there are no outliers. So what I will do, I will make outliers. So for pulse from 10th row to 15th row, I'll give value 500, which is an outlier. Now, how to detect an outlier? During all my 101s till now, very few students have been able to answer this question, that how do we, first of all, what is the meaning of an outlier? So 80% of the students, they say, sir, these are unusual values. Okay, so there is a mathematical way of answering that question. We have learned that that has been covered with us during stats 2 or maths 2.
Calculate IQR.
Yes.
Yes, sir.
1.5 times.
Actually, sir, the difference between Q3 and Q1,
Yes, yes, yes,
And
yes, yes. So
1.5
I'm,
x
It's
I'm
falling beyond the interquartile range.
yes. So I'm covering that only. It is Q1 minus 1.5 or Q3 plus 1.5. Okay, the lower bound is Q1 minus 1.5 and upper bound is Q3 plus 1.5. And then you can decide that. Yes,
So, but this 1.5 and this particular parameter, it will basically change depending on the industry, right?
depending on, yes, it will depend.
Depend, right?
This,
Okay.
this, this is a standard. If you are asked a question during your interview, please
1.5.
answer this.
It is
Please answer.
hyperparameter. It is
Okay.
hyperparameter.
Yes. So saying that
Thank
outliers are unusual values, okay, that is incorrect. So you have to say that how the outliers are related with your IQR. This 1.5 and all that you can decide, but standard it is taken as 1.5. Okay. Okay. So for example, here you can see I'm making a new data wherein duration I have given a 450 value, which is an outlier. In pulse, I have given 500, which is an outlier. In calories, I have given 4,000 an outlier. I have also made a date column, and I'm making a data frame of that. I will select only numerical columns. So I will select D types where they are only of numerical. And here I will loop through each numerical column. I will see Q1 and QR by quantile 0.25 is 0.75. I find IQR, which is Q3 minus Q1. I define the lower bound and outer bound, and then I found the outliers. And then I print outliers. So let's see whether it will work or not. So see, it has given me this code. Bounds it has given 22.50 to 82.50. This is Q1 minus 1.5 into IQR. And it has given me an outlier. So this is a mathematical way of finding an outlier. First, we have to detect an outlier. Thereafter, we have to formulate a strategy what to do with that outlier. So now, can I ask you somebody to answer what should we do with an outlier?
It will depend on the data set and the problem statement,
Sir,
whether
actually
we should
depends
keep
on
or
the
not.
contextual. In many cases, if there is a business data, then or any transaction data, then there can be big transactions or small purchases, and in
Okay.
those cases, we should leave them as they are. But if
Okay. So I will just tell you, like we dealt with NaN values, we deal with the outliers. If you find the number of rows with the outliers, they are very, very small in number to the entire data, then we may take a call that we drop these outliers. But dropping the outlier will also depend what we will do. We have got a training data. And for example, somebody has given me test data. Now for that column in which that outlier is there, I will visualize the distribution. If I find that there is an outlier in the training data, but there is no outlier in that column in the test data, then I will take a call to drop that because it will add noise to my training model. However, if I see that my training column distribution and the test column distribution, they are similar and they are having similar kind of outliers, then I will take a call not to drop that outlier. I hope
And
that
more
was clear.
rows have outlier.
Mm, Once again, sir, how to segregate the things? Once again, please, what you
Okay.
told.
So you have got a training data set, for example, here calories are here, duration is here,
Yeah.
your training data set is there, and your duration is there. In test data set, duration is there, only the target level is not there.
Hmm.
Now you visualize duration of your training data set. Here you will find that there is an outlier 450.
Yeah.
You visualize your test data set duration. There you find that there is no data which is beyond 80. So here you will take a call that I will drop this 450, otherwise it will add noise to my training model. However, if I find that there is a similar outlier in my test data set also, some value, for example, 500 or 375, then I will decide to keep this outlier. That is the basic principle.
So which one you are telling the test data?
Yes. Okay.
Okay.
Sir, may I ask you one question?
Yeah.
Say, for example, I decided to remove the outliers.
Yeah.
Now, I have got some 10, 15 columns, and each column, say, 2, 3 data are outlier. So, should we remove the entire row, or should we remove the only the exact data and replace with mean, median, mode, whatever?
Okay. We are coming to that. Replacement I will come to later. So till now, first of all, we are deciding what to do with an outlier. So first question comes whether I delete this outlier. So we are deliberating whether to delete or not. So for that, we have answered that, for example, if you find the number of rows which are having outliers, and for the number of outliers, they are very, very less in comparison to your entire data, you might take a call. But better way before deciding that is to see the distribution of that column in the training data set and the test data set. If you find that outlier is there only in the training data set, but there are no similar outliers in your test data set, I will take a call to delete it. However, if I find the similar kind of outliers are there in my test data set also, then I will take a call not to delete it. Is that okay?
Okay, sir.
Yeah,
Sir,
thank
and
you.
what if the number of rows which have that outlier is very less in both test as well as training data?
So again, you will check the distribution. I will give you an example. You have got data set, for example, 1,000 rows, and there are 10 outliers only in your training data set. Now we have to decide whether, and the column is, for example, calories, and outliers are 450, 425, 500 something. Now what I will do, I will visualize this calories column in my training data set, and I will also visualize my test data set calories. Now in test data calories, I find that test calories which are there, the maximum value is just 80 or 120. It means it is not having those outliers. Then what I can do, I can remove these outliers, or I can fill them. The next question comes to fill them. I will keep the values. I will not delete the rows. I can now fill these outlier values. Now, depending on the distribution again, whether it is normal distributed or it is skewed, left skewed, right skewed, then I will formulate a strategy to fill with mean or median. Okay. Okay.
Yes, sir.
sir.
Yes. Yes, sir.
Okay.
And
Yeah,
if
we'll
you
move
have
ahead.
one or two, then we can
Yeah.
remove that.
Yeah. Okay. Okay. Now, for example, here we have made a data set, and now we have identified the data, those outlets. So what we can do, we can remove this out if we want to remove. So what we can do, we can find those indices, outlier indices. We find that DF call, which is then lower bound, or DF call, which is more than upper bound, and we can remove them by indices. I will share this code. You can use it later. Okay. However, like just now we deliberated, we also can replace our outliers with mean, median using the replace method. Okay, so this is the replace method. We give the values, we find, and we replace. Okay, so this was using, now we have dealt with filling the data, statistical summary, technical summary, finding the n values, how to fill the n values, then we came to outliers, how to detect the outliers, what to do with the outliers. We have covered that. Now we go to the next step, finding and removing duplicates. So for that, the commands which are there, the command
Excuse me,
is
sir. The codes for the outliers you shared, scrolled. That code will be a generalized code. Anywhere we can use.
it is a generalized code. It will depend. It is a just demonstration purpose. For your use test cases, you will take a lot of deliberations. Okay.
Okay.
But these codes, they can help you. You can tweak these
Okay.
codes to make your strategy.
Okay.
Okay. All of you are diploma pass out, so you must have done all this during your MLP project. I'm sure.
Yeah.
So
Okay.
now
Not
No.
passed out. We are just doing.
Yet to do, sir.
So
Yeah.
then definitely this will help you a lot during your MLP
Yeah.
period.
Okay. Okay. Yeah. For project, it will help, right?
Yes. Now
Thank
we come to use the pandas for finding and removing duplicates. So in your data set, there may be some duplicate rows which are there. So the commands which are there is df.duplicated, which will give you the duplicates. So always remember, if I have got 3 Arjun, so it will not find first Arjun as duplicate. So, but second Arjun and third Arjun, it will give me duplicate. And for dropping the duplicates, the command is df.drop duplicates in place is equal to true. So see, this in place is very, very important. Wherever we are using, we have to use this in place. So for demonstration of this, I have made a new data set where I have created some duplicates. So here I have got Alice, and I have got here 25, 25, and then I got 30, 30, then New
you.
York, New
Bob
York.
also.
Okay. Yeah.
Bob
So
also.
first, yeah, Bob also. So first here we will find print.df.duplicated. Okay. So this is a Boolean check when it does. So if I'm using only df.duplicated, it will give me only true false. But if I want to see the rows, then it is I pass this as a parameter to df inside the bracket. It will give me the rows. Then I can use the drop duplicates, and then I can see the df.clean. Okay. I can also drop duplicate based on a column. So for that, the command is drop duplicate subset is equal to column name. So that is there. So let's see. So this is the original data frame. Alice is there. Bob is there. Boolean values. Now you can see Boolean values. It has given name. So
Subset with the name of the column.
yeah. So
And
see.
if more than 2 columns, more than one column, then we can fit by the comma
Yes.
separate.
Yes. So we can see the first will not be given as a duplicate. First Alice is not duplicate. Second Alice will be true. If you want to see df dot, so here it is given all the duplicates. So Alice 25 New York, Bob 30 Los Angeles is the duplicates. We drop the duplicates. Now we get a here. If we drop by name only, it is dropped. Okay. So this was for the duplicate and dropping the duplicates. Now next important.
Sir,
Yes.
sir, in context of machine learning, is duplicate it's also will be because in machine learning, do we also have to remove duplicates, rows or column? Or
Yes. Duplicate rows, always remember if you are understanding the concepts covered in MLF and MLT, if you have got duplicates, then your model will overfit. Remember that.
yes, sir, but if we have a large data set and if one or two column are uh,
Column,
duplicate,
col,
then
col, for column,
column,
yeah.
sorry, rows.
So rows always remove the duplicates. Okay.
Okay, sir.
Always. It is a
And
standard step. It is in the pipeline. Okay.
Remove.
yes, sir.
Now, hello.
Yes.
Yes. Any input? Any addition?
No, sir, you said always remove duplicates.
Yes, I'm saying if the duplicate rows are there, always remove. Okay. Otherwise your model will overfit.
So duplicate
Okay,
rows
sir.
Yeah,
means
even in the Kaggle assignments also we have faced like even with a single duplicate the model impacts
Yes. It
worse
will
than
overfit.
the better
Here it is basically you are all learner of data science and machine learning. You have gone through MLF lectures. You know that if you have got the similar kind of rows, my model will try to memorize that. It will get impacted. It will overfit. Okay.
and
Yes, sir.
duplicate
Now,
rows means all the column values are same or only
yes,
one
yes.
even one
All,
column.
all, all are same. All are same.
Okay. But
Okay.
name could be can have duplicates. Like some columns can.
Duplicate row means exactly it is having the same information. Okay.
Yes, sir.
Okay. That we drop. For example, if I've got 10 Arjuns but different values, then it is not duplicate. If I remove it, then it is foolishness. Okay.
Yes, sir.
Okay. Now, coming to the second concept, because this workshop is not on machine learning, but I would like to cover, if you have got columns and they are highly correlated, again, your model will overfit. So pandas gives us a tool to find that, correlation between the columns. Okay. So that is done by the core method, df.core. So for that, for example, again, I will read the data which is there, and I will see the df.core. So this is giving this core method, basically it calculates the Pearson correlation coefficient. I hope you remember this Pearson correlation coefficient. It was covered in its stats 2. And it
Yes,
finds
sir.
this, yes. So it finds this coefficient for every pair of numerical column. So you can see here, for example, with itself, the correlation will be 1. But with other columns, your correlation can vary from -1 to +1. Now see here, duration and calories, they are highly correlated. The value is around 0.92. So there is a likelihood that if I keep both these columns, then my model will overfit. So I can take a call to keep only one column out of it. Okay. With other pulse is with the max pulse, it is correlating with 0.78, max pulse with pulse only. So there are two columns.
Pardon, sir. When you told only one out of this duration and calories, only
Yes,
one will be taken for the model.
we can take. So it is hit and
Okay.
trial. I test my
Okay.
accuracy keeping that,
Okay.
but here definitely if it is 0.9, I will drop one of that. Otherwise, my model will overfit. Okay. So this is
Okay.
the df.com.
Which one we should prefer to drop? Whether the
Any
perfect.
and anything. So what you can
Okay.
do, you can take the correlation. After that, you can take see the relation between duration and your target level. You see between calories and target level, and seeing that relationship, then you can take a call which column to drop. Okay.
Okay.
Now,
Code,
so
sir.
to
Is there any code to do this? No.
huh? No, it is not a code, I guess. So
Okay.
it depends on your test case. Okay.
Definitely. A
Yeah,
function should be there to just do this. Okay.
yes. So it is not
Okay.
direct. Okay. See,
Okay.
machine learning and data science is
Hmm.
not exact, okay, calculator that you just coded, it will happen. At each and every step, you have to take decisions.
Hmm.
Okay. So
Okay.
like we have taken decisions for NAN, for outlier, for everything. It will depend on your business value. That's why we say that whenever you are having a machine learning project, first you have to study about that domain. Okay. How that small parameter which is there, it is affecting your target level. Okay.
Okay.
So for
Okay.
better understanding, could you clear one example? Say we have two features and both features are highly correlated with each other, but among the two, there is only one feature which is or more correlated with the target one. So which feature
Yeah.
we will
Yeah.
take in that
Yeah.
case?
What's a good name?
So Khushi.
Yeah. Kushi. So definitely when I will conduct a workshop on machine learning model, definitely I'll cover that. Unfortunately, this workshop is only on NumPy and Pandas, but I will try to do one thing. I will try to make a video with a collab, and maybe I'll share with all of you maybe in coming days. Okay?
That will be fine, sir. With video
Yeah.
and collab, it
Okay,
will
sir.
be
Thank
fine.
you, sir.
Yeah.
So that
Yeah.
in the same
Yes.
in the same line of
Yes.
our this
Yes. I will.
content.
I will
Okay.
do that. In
Thank
fact,
you.
at the completion of this workshop, I will share video which I made long back, and it covers all the steps of a machine learning model. It is available on YouTube. I will recommend to everyone who is a learner of machine learning. There I have covered all those steps, okay, in detail. Okay.
Please filter out, sir, because you already know the content of our course, so we will learn
Yes,
better
yes.
because
So
a number
I'll
of
share
things are
that.
there.
Okay.
Okay, fine.
So I'll
Thank you.
share that with all of you. Now to just show this correlation again to all of you, I have made a artificial database, and let's see. And after that, I have tried to see the correlation between this. So I have, so there are 1, 2, 3, 4, 5 columns. There are study hours, grades, sleep hours, fatigue, and height for students. So here we see study hours and grades, they are highly correlated. Whoever has studied more, he has got good grades. Okay. Similarly, grades with the study hour, no correlation. Sleep hours, see, sleep hours is negatively with fatigue. More you sleep, less you get fatigue. Okay, so that is there. So
Right.
yeah, so it is there. So here you can take a call. So what generally we do, Khushi, you are asking me. So see, straight away we don't decide which column to drop. So what do you do? First you keep all the columns and then you train your model. You see the accuracy. Okay. Then you drop one column and then you see the accuracy. Third, okay, then you drop another column, then you see the accuracy. So whichever is giving you best accuracy, and you are using the validation set also, that those columns you keep. So that is how it is done in the real world. Okay. So
More
these are,
question. One more
yeah,
question.
yeah,
Positively correlated and negatively correlated both are there. If
yeah.
the negatively correlated is also same, then we can drop on the basis of that
Yes,
also.
yes, yes,
Okay.
yes. Both
Okay.
are there. Okay.
Okay.
Okay. So these are the pandas main functions which we use in a data science. How to find. So NaN I have covered, outlier we have covered replace, we have covered drop NA, we have covered drop also, we have covered this correlation also. So these are the standard ones. Now pandas has got basic visualization library also. So if I want to visualize this correlation, then I can visualize this, for example, using heat map. So for that, I'm using the Seaborn. It is a visualization library. I'm importing matplotlib, and this correlation matrix I had made here, and I can visualize this. So then it gives me the visualization form. So here it has given me study hours and grade 0.96, grades and study hours 0.96, sleep hours and fatigue is negatively correlated. So from here I can see visual, see it visually, and more it goes towards red and blue. It means they are either highly correlated in a positive way or in a negative way. Okay. Now, this was about the Pearson's coefficient. Now, pandas support three main types of correlation coefficient via the method parameter. So, depending on your use case, your business case, what you're doing, so either we can use Pearson's. So, Pearson's measures the linear relationships. It is sensitive to outliers. So, before doing this, we have to deal with the outliers. And it is used when the data is normally distributed and relationship looks like a straight line. The second method is Spearman. Spearman is a rank-based correlation. It measures monotonic relationship, whether y increases when x is increasing, even if not in a straight line. It is robust to outliers and non-linear data. So after seeing the distribution of your data, you can take a call whether I have to use Pearson's or I have to use Spearman. The third method is known as Candle. It is a rank-based, which is depending on Candle's tau. It is similar to Spearman, but often better for a smaller data set. So if you've got a smaller data set and your relationship is not linear, then it is recommended to use Candle one. So to demonstrate this, I have made a data set here.
Now,
So
how we will segregate this? This one is candle or this one is a spear,
okay,
man?
so see when you visualize a data, for example, X and Y, they have given you relationship, for example, 0.9.
Hmm.
And when you visualize that and you are seeing a straight line, linear relationship, then you immediately you decide that I will use Pearson's. Now,
So
if you
for
see
that
it
we
is
have to
a
plot. We have to plot the
yes,
data first.
yes, yes, yes. So in data science, visualization is a very, very important thing. Okay, and that's why we have got a separate workshop for visualization. You use visualization during EDA while doing all this feature engineering everywhere. You use visualization. Okay. Okay. So for
Okay.
that, I have made a data where I have kept a non-linear and I have kept a outlier. And here I have found those Pearson's coefficients. I've used Pearson, then I've used Spearman. So both have come. So see, for non-linear, it has come 0.9. With outlier, it has come 0.4. So it gets affected by the outlier. That is it. Okay. Now, this was the statistical things which we can do with pandas. Pandas also come with a basic library for visualization, which we can straight away use. So we will read our data which we have stored, and using the pandas, for example, df.plot, just by plotting, we can see the values of duration, pulse, max pulse, calories, their distribution. For example, if I want to see only for duration, I will just get duration dot plot. Okay. So see, this is your distribution of your duration. From this value to this value, I can see for other also. So first, let's see.
So your y-axis is the frequency, right? The count.
Yes, yes. Let's see for calories also. So we can plot two also. For example, I want to plot duration and pulse. I can do that. But I would like to share with all of you that generally in the real world, we don't use pandas for visualization. Generally, we use matplotlib or we use Seaborn. They are the highly used libraries. In many cases, we use Plotly also, which is very highly interactive. Okay. If, for example, you want to plot a scatter plot using that, so here we give kind is equal to scatter. We give the column name of both the names. So now for scatter, we know that we have to give X value also, Y also. So we can see, so this scatter plot is basically used to find the relationship. So see here, duration and calories. So duration is on x-axis, calories is here. So we can see that there is some kind of linear relationship which is existing. Okay, and there are one or two outliers which are there. Now, same thing if I want to do with duration and max pulse. Let's see. So here I see there is no relationship. The data points are scattered all over. Okay. We also can plot
Pandas or matplotlib. This plot,
Huh?
this scatter plot is given in
This is
pandas.
no, this is pandas df.plot.
Yes, okay.
Okay.
But this is similar to matplotlib's scatter
Yes,
plot.
yes. See, matplotlib is basically in fact, your basic Python has also got visualization. Pandas got visualization. All these libraries, further libraries are basically wrappers. They keep on adding advanced features. Okay.
Okay.
Now, by kind, if we pass hist, then we get a histogram. So for duration, we see, so we can see it is this kind of distribution which is there. So if I ask you somebody, for example, if there was a NaN value, what should we choose? Mean or median?
Median, sir.
Yes, good. Okay. So with this, friends, I have finished this workshop. It was a fantastic time spending with you, interacting with all of you. And I will be releasing this assignment maybe tonight. And you have got time till tomorrow, tomorrow night, till 10 o'clock in the night tomorrow. So you'll have entire 24 hours. Assignment will be, good. I will give you a real world data set and I will ask you questions from that. So whatever concepts we have covered, the questions will be from that only. There will be some evolved questions and definitely I'm sure that you will enjoy solving that. So with that, I have finished. If there is any query, anything you want to ask, if you want to ask me any question beyond this domain also, I am free. I will be happy to answer.
Sir, you said in the middle that you have a YouTube channel and you are supposed to
Yeah.
press the.
Okay.
Yeah.
Okay. I will share that. Okay. Definitely, maybe I will send an email to all of you. Okay.
So can there be a one-day extension for working people?
What, Shamanta?
So can there be an extension for one-day working people actually?
You are not audible. You are not audible. Sorry.
Can you hear me now?
So he is
There is a lot
asking
of
for
echo
extension.
in the background. For extension for what?
I guess For assignment, I guess, for the working
See,
professional to extend
initially I had
progress.
covered on day one that your assignment you have to complete in 3 hours. After that, there were a lot of requests from the working professionals from everybody. That's why I have decided that I will release it tonight, and you have to submit. 24 hours is hell lot of time to submit this assignment. Okay, yes, Kaushik.
Sir, I have two questions. One, you have just mentioned the correlation coefficients like Pearson's, Spearman, and the other one, Kendall. So
Yeah.
for non-linearly correlated data, besides Spearman, do you have any other coefficient? Suppose the data is like the two variables and they are non-linearly correlated, say in some non-linear pattern. So is there any way to measure that statistically besides the Spearman? If I understand, Spearman is used for non-linearly correlated.
Yeah, so there you will not be using the coefficients, but you can visualize the counts of those categorical data. For example, there is a categorical column. It contains, for example, apple and mangoes only. Okay, and there is a target label. So you can visualize that apple and oranges, and on a bar, it will give you the number of oranges and number of mangoes. And it also you can visualize the hue that out of how many oranges your target label is yes, out of how many the target label is no. So that kind of visualization is possible.
So, but will that give me a quantification for any non-linear correlation between, let's say, apples
No.
and oranges?
No,
Right?
no.
So it's just for visualization. I mean, I can do a visualization, but
Yes.
it will be difficult to quantify for, the correlation if the data are non-linearly correlated.
So if you have gone through the Stats 2 course, we used to have something called the Chai distribution.
Yes, yes.
Okay, it was like that. So we have got other methods to find those kind of correlation.
Okay.
I will recommend to you. So this workshop was about NumPy and Pandas only. That's why I have not covered. So those statistical methods are there. You can do that.
Okay, sir. Thank you. And the second question is for the test for the assignment that we have to do, will it be on Colab or do we need to use an ID or do we have the option of using either?
No. So what I will do, I will give you a PDF file. PDF file consists of the source of the data. You have to download that data set. And after that, for every question, you will get some answers. Okay. That you can do whether in your Jupyter notebook, you can use Colab, you can use Kaggle, but you will be submitting those answers to a form.
Okay, so it will be a G form. We'll work it out ourselves and then
it will be a G form. Yeah.
Okay, sir. Thank you.
Sir, I mean,
Satrati, please. Satrati, you're in a queue. Mayank, please.
Sorry, sir.
Yes, ma'am.
Yes, sir. You have told, sir, by today you will release the questions, and we will get by tomorrow. We can complete this. No.
Yes.
So actually, I am having my train at 3 a.m. So can you just saying at what time till you will release approximately?
I'll release by around 10 o'clock.
Oh, okay, sir. Thank you, sir.
Yeah. Yes, Prashant.
Yes, sir. You said for linearly correlated data, we use Pearson correlation coefficient, right? And with less outliers.
Yes.
And if we have outliers, then we use the other ones, right?
Yes.
Like the Spearman or Kendall.
Yeah.
And if there are no outliers and it is not linear, this non-linear associations.
So
then
non-linear
for the others.
Spearman.
Okay, and if it is both, then definitely you have to use Spearman, not the Pearson code.
Yes.
And if the data set size is less, the number of rows, then we should use Kendall.
If it is non-linear and the data set size is less, then we use Kendall.
And also it has outliers.
Yes.
And then if the number of outliers are less, then also we should prefer using the other one, right? Not Pearson.
Yes.
Even if the proportion of outliers are small.
Yes. Yes, Satyajit.
Okay, thank
sorry
you.
for the previous issue, sir. And I just wanted to ask one question. Previously in the MLP and BDM assignments, I mean, we had these kinds of assignments, and one particular issue I personally faced there was about rounding. In many questions, we had like this that if an particular answer, if any particular answer comes out to be like 1.271, but the system will only register it as correct if
Okay,
it is
okay.
only rounded
So
at
so
1.27. So
so don't worry. You answer in up to two decimal places. Don't worry. I'll keep the ranges in mind. Okay, don't worry about it. Okay.
yes, sir.
Yes,
Thank you,
Shrikant.
sir.
Yes,
Yeah,
Shrikant.
sir, I was out of this way. The MLB projects also boot camp is there organized in the MLB projects also.
That I'm not aware. I'm not sure. I'm not the right person to
You
answer.
you do not do boot camps, only workshops you are conducting.
What WhatsApp means?
Workshop. You do only workshop kind of thing,
Yes,
not boot
yes,
camp.
yes.
Okay.
No.
Okay. Our second question, you told no, the videos regarding the pandas and numpy contest and the theories. When you share these collabs, also write the text also, so which is related to the like, whether we should suppose we want to revise it some after some time, then it should be there because this will be beneficial for us.
See, in college, like, wherever like, explanations are
Yeah,
required, I've
yeah,
already written those like, explanations.
yeah.
Everything is there, so I'll be sharing the entire collab with you. All of you.
Yeah, tomorrow, yesterday's was there. Tomorrow, today's you can do whatever it is required,
Yes,
if it is possible. And second, the videos you are telling the concerned video, we are unable to do the filtering because we don't have time. A lot of things are there. So because you know the concerned thing, you will go through that the videos.
yeah, okay, yeah, will do.
Okay.
Thank you.
Yeah.
Yeah.
Okay. Thank
Yes,
you. Thank
Fazal.
you.
Sir, I wanted to remind you once again about the timing clashes of the data visualization
Yes, yes,
workshop
I'm
and the
I'm
grid
I'm
workshop.
I'm aware of it, Fazal.
Okay, sir. Thank you.
Okay, we'll take a call. It's still few days are left. Okay, we'll collaborate with that instructor. We'll take a call. Don't worry about it. Okay.
Okay.
Yeah. Okay. Thank you. If there is no other query, thanks a lot for joining this workshop. Thank you
Thank
for
you, sir.
interacting and
I like
thank you
it.
for asking those
Great,
fantastic
Thank you, sir.
questions. Thank you.
great
Have a
sessions,
nice
sir.
day. Bye bye.
Thank
Take
you.
care. Bye bye.
Thank you.
Sir,
Thank you.
Thank you for the workshop, sir. Thank you.
Yeah. Thank you.
sir, you said that when there are no outliers in the test data, then we can safely remove the outliers. But what if there is only like in the test data as only one less than 1% of the test data as outliers?
Prashant,
Then also,
Prashant, I will recommend you should be careful while listening to, I have covered in very, very clear cut terms. If you have got outliers in the training data set and if you don't have those outliers in the test data set, you can remove or you can fill them with mean, median, or mode, whatever the strategy. But if you find that similar kind of outliers are there in your test data set, then it is recommended to keep that outlier. Okay?
even if the proportion, the number of the percentage is very small.
Do you want your model to learn about that or not if it is there in the test data set?
Yes,
Tell me
yeah.
this answer.
Okay, if it is in test, yeah, then however small it is better to learn.
Yes. Okay. Okay. Thank you. Thank
Yes.
you for participating. Have
Thank
a
you.
nice day. Bye bye. Take care. Bye bye.